Welcome to this presentation of Mukana Trust Center. Trust Center is a horizontal platform for embedded trust and convergence of information technology or IT systems and operational technology or OT systems. Let's look at how Trust Center provides network traffic protection without re-engineering your line of business applications. What are the imminent risks that Board of Directors and Chief Risk Officers must address today to protect their mission-critical industrial control and healthcare systems? Nation-state actors are targeting OT systems such as electric grids, water treatment plants, and HVAC equipment. Malware is outpacing current detection and prevention methods, morphing at a rate faster than reputation lists, signatures, and grammar expressions. Breaches in OT systems can cause severe outages, disruption of essential services, and brand damage. Cyber protection for network traffic encryption with authentication, integrity, and confidentiality for secure data sharing and high assurance command and control is the foundation for zero trust networking in industries such as smart energy grids, additive manufacturing, digital healthcare, industrial control systems for process control and automation, and AI ML based innovation and optimizations with digital twins. Mukana's Trust Center is a device and silicon vendor friendly trusted platform designed to support brand name industrial grade devices and silicon chip makers and accelerate mainstream adoption of hardware based security functions and root of trust anchors. Trust Center may be hosted on-premise or in the cloud as a SaaS model, driving revenue streams for managed security service providers and helping device vendors harden devices for high assurance of operational trustworthiness. Device vendors deal with several technical challenges, increased software engineering costs, and stretched product release cycles in transforming devices for cyber resilience, such as ensuring interoperability between greenfield, brownfield, and legacy devices, eliminating the complexity and cost of PKI build-out, securing machine-to-machine communications with low latency, re-engineering their line of business applications for security, protections for containerized applications, and achieving compliance objectives such as IEC, FCG, Nergship, NIST, and IEEE. Trust Center services dovetail seamlessly into the Purdue model for industrial control systems, at Layer 3 for operations and control, at Layer 2 for area control, and at Layer 1 for asset protection. Trust Edge clients provide network layer encryption for unicast, multicast, and broadcast traffic with automatic session key rotation and interoperability between greenfield and brownfield devices without requiring any application reengineering. The Trust Center solution enables IT/OT convergence with a unified workflow for enterprise device management system, security operations center, and plant operators. The Trust Center Cybersex solution, based on the Group Domain of Interpretation or GDOI standard, supports group keys and group memberships to establish secure communications between authenticated group members. The GDOI protocol alleviates the intricacies of key exchange, key rotation, and key management between peers in a group domain. The Cybersec client installed on group members coordinates automated group key exchange and key rotation based on the configured rekey interval and ensures continuity of operations during rekey negotiations. The Cybersex server at the epicenter of security orchestration serves as the Key Distribution Center or KDC and may be installed on-premise in the plant DMZ. For service level failover, Trust Center may be configured with primary and secondary Cybersex servers ensuring high availability. The Trust Center Cybersex service overcomes deployment challenges imposed by network segmentation, tiered network fabrics, and routers in multi-site ecosystems. Encryption of multicast, broadcast, and unicast TCP and UDP traffic is performed seamlessly using GDOI-based group key management. The CyberSec clients are supported on Linux, Windows, VxWorks, and QNX platforms to provide broad coverage for controllers and HMI workstations in industrial control systems, healthcare ecosystems, and energy grids for protection at the epicenter of mission-critical operations. The CyberSec client for Linux and RTOS platforms is implemented as a kernel mode IPsec driver and built for the matching kernel version installed on the target operating platform. The GDOI client implements the IKE version 1 protocol for interactions with the GDOI server on the CyberSec server. The CyberSec clients authenticate with the Cybersex service to retrieve session keys based on the configuration for multicast, broadcast, and unicast communications with designated peers. The CyberSec client for Windows platforms is implemented as a user mode IPsec service with an underlying NDIS intermediate driver as the kernel mode network filter. The GDOI client implements the IKE version 1 protocol for interactions with the GDOI server on the Cybersex server. The CyberSec clients authenticate with the Cybersex service to retrieve session keys based on configuration for multicast, broadcast, and unicast communications with the designated peers. Trust Center CyberSec also provides support for network-level failover with network redundancy. The CyberSec client and server nodes may be multi-homed systems. The CyberSec client automatically detects loss of network connectivity to the Cybersex server and recovers by switching to the failover channel. The network status tracker uses periodic heartbeats and a status table for optimized failover with low latency. Let's look at the two main phases of CyberSec protection. Phase 1 is the authentication ceremony, wherein the CyberSec client-enabled devices on the network must authenticate using a trusted and immutable device identity with the Cybersex server or key distribution center. The identity may be based on a hardware, firmware, or software-based root of trust anchor on the device. Optionally, the Trust Center enrollment service may be deployed to comply with IEEE 802.1 AR standards and achieve a higher IEC 62443 security level. Cybersex supports mutual authentication with a pre-shared key or PSK, or X59 certificate-based client authentication and certificate-based server authentication. Post-device authentication, the client proceeds to Phase 2 for key exchange. Phase 2 comprises of a handshake for group key exchange between the key distribution center server and the authenticated client. Based on the configuration settings and policies for each CyberSec client member device, the Cybersex server generates and distributes session metadata to the clients to establish security associations between other unicast members and multicast or broadcast groups in the data plane. Once the key negotiations are complete, operations commence to protect network communications with authentication for data integrity and optionally encryption for confidentiality to prevent malicious intercept or tampering of command response sequences. For example, between HMI workstations in the DMZ network layer 2.5 and controllers in the basic and area control layers 1 and 2. The members must renegotiate the cryptographic artifacts and policy metadata at the configured rekey interval. Metadata synchronization between primary and secondary Cybersex servers ensures service level failover protection. Let's further examine 4 use cases of significance. A client at an operator workstation in the DMZ network may send a UDP query to controllers at layer 2 as a multicast transmission. All members of the multicast group receive the query. In response to the multicast query from the operator workstation, one or more controllers may send a UDP reply to the query as a unicast transmission to the operator workstation, thereby protecting the privacy and confidentiality of the response from other group members. Let's examine another use case. The operator workstation may need to communicate exclusively with a particular controller over a UDP session. In this case, a UDP group comprising of 2 members may be configured for peer-to-peer traffic protection. The IPsec rule may be configured to apply to any remote port or to a specific port. Let's examine yet another use case wherein the operator workstation may need to communicate exclusively with a particular controller over a TCP session. In this case, a unicast group comprising of 2 members may be configured for peer-to-peer traffic protection. The IPsec rule may be configured to apply to any remote port or to a specific port. Interoperability between greenfield and brownfield devices is of paramount importance to ensure non-disruptive and incremental modernization to achieve digital transformation of the infrastructure elements. CyberSec provides a dual mode of operation to manage broadcasts from greenfield devices with a split mode of egress packet processing at the IPsec layer. Broadcast traffic is automatically mapped to multicast addresses to encrypt traffic destined to greenfield devices on designated ports. Greenfield devices may therefore communicate securely with encrypted broadcast traffic and broadcast unencrypted traffic to brownfield devices in the network fabric. Interoperability between greenfield and brownfield devices requires policy-based selective encryption of network traffic. Therefore, brownfield devices incapable of handling encrypted IP traffic gracefully must receive unencrypted IP broadcasts from greenfield devices. The dual mode of operation allows greenfield devices to send and receive encrypted traffic based on the configured group memberships and negotiated security association, and brownfield devices to only receive unencrypted traffic. Unencrypted traffic received on greenfield devices is blocked by an IPsec rule to ensure all ingress traffic is encrypted to prevent database attacks. The security features provided by the Trust Center CyberSec platform add protective countermeasures for risk management and high assurance of runtime operational integrity. It implements the Group Domain of Interpretation or GDOI client and server described in RSC 6407. It provides group membership-based secure encryption domains. Members may be added or removed dynamically without service disruption. Members may belong in multiple non-overlapping multicast and unicast groups. It provides transport mode of IPsec operation. It uses the IKE protocol for pre-shared key or certificate-based device authentication and Diffie-Hellman for secure key exchange. It provides data encryption with IPsec encapsulated security payloads. It provides data integrity with IPsec authentication headers. The benefits of the Trust Center CyberSec solution architecture extend beyond protective countermeasures. It provides a zero-coding approach to modernizing infrastructure without re-engineering existing line-of-business applications. It supports any certificate authority of choice for PKI-based security. It is a multi-platform solution that is operating system and processor agnostic. It supports hardware acceleration based on the underlying CPU, MCU, or SOC capabilities. It supports NSA Suite B and NIST-approved resource-constrained and post-quantum ciphers for FIPS 140-3 Level 1 certification. It provides a secure policy distribution point for supply chain integrity. It helps achieve IEC 62443, Nergship 5-5, and FCG compliance. Achieving compliance objectives is driven by factors such as device owner or operator requirements for safety and cybersecurity based on industry sector. Attacks on critical infrastructure requires thought leadership and innovation, as engineering development cycles for software and firmware releases to field upgradable devices is a tedious process. The fundamental foundational requirements of IEC 62443 for non-real-life devices include device identification and authentication, data protections for privacy and confidentiality with key protection, and device recovery for high availability to prevent service outages. The security level desired from level 1 to level 4 must be established based on the tools and methods in the arsenal of the cybercrime syndicate and the level of motivation to orchestrate attacks on the device type. Both gaps in process that an insider threat may exploit and exposures that an external nation-state actor may exploit must be factored into the risk model for assessment of required countermeasures. The requirements for Nergship compliance include asset identification, strength of authentication controls on the device for interactive access, namely use of passwords and certificates, network security architecture, and encryption controls. In the context of connected devices and lateral threats posed by landed malware in the control and data plane, the strength of protection must mitigate password and data-based exploits by advanced persistent threats with key protection and certificate lifecycle management for key rotation. Group memberships are based on explicit trust. Device authentication is a critical control for secure group key distribution to prevent an untrusted device from exploiting session keys for nefarious purposes. For backwards compatibility, Cybersex supports the use of pre-shared keys, a common practice in industry today. However, shared secrets are insecure, require cumbersome manual provisioning, and tight synchronization between group members that may cause service disruption during key rotation. Use of pre-shared keys pose risks in the ability to block unauthorized members and insider threats. Cybersec provides certificate-based authentication with unique device identifiers from a root of trust anchor on the device for high assurance, in accordance with the Enrollment over Secure Transport Protocol described in RFC 7030 and the IEEE 802.1 AR standard for use of initial and local device identifiers. Cybersec provides granular controls for addition and revocation of membership, key rotation, and certificate renewal without service disruption. Cybersex supports encryption of multicast traffic between members of multicast groups. The encryption and authentication algorithms and keys are negotiated and exchanged using the GDOI and IKE protocols between the Cybersec clients and the Cybersex server based on security policies configured at the key distribution center. Cybersec provides extensions beyond the scope of the GDOI specification to support encryption of unicast, UDP, and TCP traffic. The keys between peers may be specified to the granularity of a subnet, address range, or address list. For interoperability between greenfield and brownfield devices in the network fabric, Cybersex supports the dual mode of operation for broadcast traffic. Broadcast traffic between greenfield devices are encrypted, while traffic to brownfield devices remain unencrypted. The policies to selectively encrypt broadcast traffic may be configured with granular map and port list entries. Cybersec provides key protection for device authentication with a secure element on the device where applicable, and network traffic encryption for data protection. The Cybersex server performs the Key Distribution Center or KDC function. The session keys across all configured multicast, broadcast, and unicast groups are automatically rotated based on the configured rekey interval with an overlap window for switchover. System and device level status monitoring and change notifications are critical for device management system and security operations center operators to ensure 24/7 operational integrity without service disruption. Cybersec provides event logs for client and server status monitoring and change notifications for timely intervention. Emerging compliance standards and security guidelines for data encryption and key protection pose challenges for traditional network-based intrusion detection, prevention, and monitoring systems. System status and traffic monitoring remain essential supervisory and audit controls. Decrypting the IKE messages and encrypted IPsec payloads of a session require use of the encryption and authentication algorithm and keys. The Cybersec client provides security administrators a permissioned utility to extract session information for troubleshooting purposes. I hope you found this brief presentation informative. You may contact us at www.mukana.com for a live workshop. Thank you.